All right, so in our last class, we left off working on the calculation of the pH of a strong acid with a strong base. We were looking at, we had three general areas that we really care about. Well, four really. The initial, right here before you've added any of the titrant. Then you have the section right before, from there all the way to just before the big steep increase in the pH with the added base, small amounts of added base. And then we had the equivalence point, which is hopefully the same point as your endpoint. And then we had after the equivalence point. And so we'll look at each of those as and sort of review what we did yesterday. Now we're only going to do the strong acid, strong base right now. Hold on one sec. All right, so we're only going to do the strong acid, strong base today. We'll pick up with the weak acid, strong base tomorrow. So we've already looked at the calculation of the pH of a strong acid, strong base titration before we add anything, right? That was when we only had a solution of acid. The pH is determined by the concentration of the acid because we said that acid dissociates completely. That was our main one last time. Come on, moving, there we go. We then looked at the pH when we had added 25 milliliters of base. So this is between the initial point where before we've added base and the equivalence point. And that is again based on the concentration of the acid, only now our acid is less concentrated because some of that strong acid has reacted with the strong base that we've added to neutralize it, essentially turn it into water. And so what we were interested in is first we had to look at the moles of acid that we started with. Right? And so we looked initially at our moles of acid that we started with and the moles of base that we added. The difference between those two, in this case, told us how many moles of acid were remaining. And so we got the moles of acid remaining from that. We plugged that into just a molarity equation where we had 0.25 moles of HCl divided by the new total volume, which is the initial volume, the so the 50 milliliters plus the added volume of the 25 milliliters, right? And we wound up with a concentration, right, of HCl or of the strong acid that remained in that solution. And that's where we just use that to calculate what just happened? We use that to calculate back here. There we go. The we use that to calculate the pH, right? And so you just plug in that new concentration after the added strong base, and that's what gives you, so negative log of the concentration gives you the pH of the solution. Next, we're going to look at the pH at the equivalence point. So here at the equivalence point, and you can calculate the equivalence point based on how much stuff you've added. If you've done a titration where you've added an indicator, for example, phenolphthalein that you used, you would be able to calculate the added volume when you reach that end point. And that end point should tell you how many moles of each that you had. So here, it's easy to identify the equivalence point because we can say, well, we have an initial concentration of hydrochloric acid that's the same as the initial concentration of sodium hydroxide. So in this example, when the two volumes of acid and the volume of base are the same, you kind of know that's the equivalence point right now for these this monoprotic acid with the alkali metal hydroxide. Okay. So at this stage, and let's just do the calculation to make sure we know, but we're going to take first the moles of acid that we got from the previous step because we don't need to do that calculation again. So we've got 0.00500 moles of HCl, right? And so that's our initial moles of acid. Okay, and so that we know is 0.00500 moles of HCl. Okay. Then we want to see, just to be sure that we're at that equivalence point, the moles of base added. Okay. And so to do that calculation, it's pretty simple. We just take, again, the volume times the concentration of the base added. So we had our 50 milliliters, so 0.0500 liters of the base. Multiply that by its concentration, 0.1000 moles per liter, moles in this case of sodium hydroxide. And we get a value of 0.00500 moles of NaOH, okay? So in this case, since those two values are equal, we're at the equivalence point. And you can sort of prove yourself to that, or prove that to yourself by saying, well, we have the amount of moles of HCl minus the moles of, or the moles that would react with the sodium hydroxide. So 0.00500 moles of NaOH times the mole ratio, right? 1 mole of HCl per mole, or 1 mole of NaOH, right? And you'd wind up with 0 moles of HCl remaining. Okay. At that point, that says that all of the HCl is neutralized, right? So you've turned all that HCl into water. Well, the pH of just water, well, now you have water, but you have sodium ion and you have chloride ion in it, but those are both neutral ions. So your pH at that point is just 7, okay? So you really don't need to do much at that point because, hey, if you know it's the equivalence point of a strong acid, strong base titration, at the equivalence point, the pH is 7. So let's go back and look at our graph up here, right? So this is for the strong acid, strong base equation. The equivalence point is there is going to be 7. What we're going to find out is that the equivalence point of a weak acid, strong base titration is not at 7. That's something we'll see a little bit later. But if you know, and so that's something you'd have to calculate in a different way. If you know it's a strong acid, strong base, you can just say, hey, pH is 7 at that point. Okay. So that's the third of the 4 points in the titration of a strong acid with a strong base. And so we didn't even need the extra slide that I put in for that one. Okay, so the fourth point is basically any time after you go past the equivalence point, okay? And so what we can do again is we can say, okay, well, the moles of HCl that you had initially, right? We're going to still stick with that, 0.00500 moles of HCl. We can calculate now the moles of sodium hydroxide added. Okay, and we do that in the same way. We have, in this case now, we have 75 milliliters of the base. So 0.075 liters. We have the same concentration, 0.1000 moles of sodium hydroxide per liter. So it says that we now have 0.00750 moles of NaOH added, okay? So here, the next calculation we want to do is we want to say, well, what are the moles of excess base added? Right, and so from that's really something you should be able to see by the fact that this value here for the moles of sodium hydroxide is larger than the value for the initial moles of HCl. And so we can go and just use that to our advantage and say, okay, well, 0.00750 moles of sodium hydroxide are essentially what you need to begin with and say, well, I can subtract off the moles of sodium hydroxide that have reacted because I know how much HCl I started with. And I know that it's a 1-to-1 stoichiometric mole ratio for this reaction. So 1 mole of HCl for every 1 mole of NaOH. And so from that, you wind up having 0.00250 moles of sodium hydroxide remaining. Okay. Now, if you have sodium hydroxide remaining, that means you're going to look for the hydroxide ion concentration because it's a strong base. And so we'll take that into our next slide. So 0.00250, so 2 moles of NaOH. Divide that by the total concentration, the initial, which was the 0.0500 liters, plus the added volume, 0.0750 liters. That's not good. There we go. So you get 0.00250 moles per 1250 liters. Okay. And so all you have to do there, a little bit of math, you wind up with the concentration of sodium hydroxide remaining. That is 0.0200 molar. And from that, you can figure out your POH, right? Negative log of the concentration of sodium hydroxide. Okay, or negative log of 0.0200 gives you a value of 1.699. Okay, and so then your pH will just be 14 minus that. Okay, so you wind up with 12.301 as the pH for the solution where you've added 75 mils. Again, this is after the equivalence point. You're now looking for, again, this is the key here. You're looking for the, try that again, highlighter, there we go. You're really looking for the amount of sodium hydroxide that's left over in the solution, or that you've titrated beyond the equivalence point. That's going to be what gives you your, again, POH, just like we did when we did the pH of a basic solution. This is a basic solution now, and so from the POH you can calculate the pH, right? And so that's where you get there. Okay, so hopefully that's pretty straightforward for you. You know, the calculations of the pH of a strong acid, strong base titration, they're pretty straightforward. You're really just looking for what do you have more of? Do you have more moles of the acid? Do you have more moles of the base? Whichever one you have more of, you divide that by the total volume. That gives you your concentration of either H plus, or hydronium rather, or hydroxide. If it's hydroxide, you get the POH, and then the pH from that. If it's hydronium, you get the pH directly from the remaining concentration, okay? And so that's really enough information now to do that first lab that we have for today. And so with that, that's all we're really doing for class today. So it's a really short video for today. So I'm going to stop our recording and open it up to other questions, and we can talk about lab.